Part two of this now. So there's two types of angles that you're going to need to know to start off. One of them is called a central angle, right? Central angle. So this is an angle whose vertex is the center of the circle. It looks like this. Radius, radius. Two radii get put together. It's always going to have that O as its vertex then, right? The center will always be the vertex of the angle. And it's going to look just like this. All right, so you have to be comfortable with what it looks like. So in this case, this is angle AOB. Well, no surprise that O is the middle letter because it's center O, because it's circle O, right? And that's what a central angle looks like. Almost looks like a slice of pizza, right? Your piece, my piece. All right, so here's the deal. I'm going to start with this guy. If this angle, you know you measure angles in degrees, but you measure arcs in degrees too. If this angle is 90 degrees, and it certainly looks like a right angle, well, hold up. This is a quarter of the circle. So you'd expect if this is 360 around for this to be 90 degrees too, and it is. And the reason is, with a central angle, the angle and the arc are equal. Now, there's a term I need to teach you here. This arc, I want you to think of it as like a mouth, right? The portion of the circle that it's eating is called its intercepted arc. So the intercepted arc of this 90-degree angle is from here to here, and it is 90 degrees because the intercepted arc and the angle are the same for a central angle. All right, now, so if this is x, this is x. So if you know the arc, you know the angle. If you know the angle, you know the arc. It can go either way. So that portion of the circle is called the intercepted arc. I didn't space that out well, sorry. All right, okay, some theorems to know. 3, and really it's 2. So, congruent central angles have congruent arcs. We just said that, all right? Now it's the reverse. Congruent arcs have congruent central angles. Well, we said that too. So here's a picture that goes with the first bullet, second bullet, third bullet. So, if let's say I drew these two intersecting diameters, well, that's intersecting lines. Intersecting lines form congruent vertical angles. So I would know these two angles are the same. Well, if these two angles are the same, and they are central angles, because I said they were diameters, and the vertex is the center. So if these two congruent angles are there, then these two arcs, the intercepted arcs for these two angles, arc CA and arc BD, they would be congruent as well. So the congruent central angles give you congruent arcs. Now, they don't always have to look like that either. Maybe the picture is a little funkier. It looks like this. If I tell you instead that the arcs are the same, you can conclude that the angles are the same. All right? And finally, and this is the one that's the most complicated of the three, if you have this diameter and it's perpendicular to this chord, all right, it does some funky things. So what it does is it bisects the chord. So CD just got bisected. So CE and ED are congruent. You can put slashy things there. Arc AC and arc AD are congruent. And the bottom ones too, CB and BD are congruent. All right, so these two arcs are the same. These two arcs are the same. These two chord pieces, these two segments are the same. And since you got a right angle here, because of course it's going to form right angles, sometimes they'll draw in the radius here. Well, now you got a right triangle. Well, if you got a right triangle, now you can have Pythagorean theorem. Maybe they tell you this is 3, they tell you this is 4, and they ask you to figure out the radius. 3, 4, 5, right triangle or Pythagorean theorem. All right, so that's central angles. All right, I'm going to stop this and do the next one in another video.